multiplication. This is our topic of presentation. Cayley-Hamilton theorem. The statement of the theorem is every square matrix satisfy its characteristic equation. Every square matrix satisfies its characteristic equation. This is the statement of Cayley-Hamilton theorem. मतलब ये कहने का है कि हर एक स्क्वायर मैट्रिक्स अपनी कैरेक्टरिस्टिक इक्वेशन को सेटिस्फाई करता है. So, taking this Cayley-Hamilton theorem, we shall discuss one example. We have a matrix A. This is a 2 by 2 matrix, 1 minus 1 minus 2 1 4. So for this matrix we can find out the characteristic equation. The characteristic equation is A minus lambda I determinant is equal to 0. This is we have already discussed how to find out a characteristic equation. So that come out to be A minus A come out to be 1 minus lambda minus 2 1 4 minus lambda is equal to 0. Now you can expand this determinant and it come out to be this equation. So solving this equation a little, this come out to be lambda square and minus 5 lambda and plus 6 is equal to 0. This is the characteristic equation we have. And what about this by Cayley-Hamilton theorem? By Cayley-Hamilton theorem, we know that Cayley-Hamilton theorem ये कहती है कि हर एक स्क्वायर मैट्रिक्स अपनी कैरेक्टरिस्टिक इक्वेशन को सेटिस्फाई करता है. सेटिस्फाई करता है मतलब जो स्क्वायर मैट्रिक्स A है, this is a square matrix A and it should satisfy this equation, mean A square minus 5A plus 6 should be a null matrix, 0 matrix. This is the meaning of Cayley-Hamilton theorem. So therefore, let us find out A square first. A square means multiply A with A. So this is A matrix and this is A matrix. So you will get A square. So 1 into 1 minus 2 minus 2 into 1. This come out to be minus 1. So this come out to be 1 into minus 2 and minus 4. Minus 10 minus 8. Minus 10 बन जाएगा. 1 is to 1 plus 4 is to 1. That is 5. And this is minus 2 plus 16. This is 14. So this will be your A square. Name it as equation number 1. So therefore A square minus 5A plus 6 should be 0. ये 0 आना चाहिए. 0 मतलब null matrix आना चाहिए. तो A square का value substitute करिए. This is your A square and 5A. Put the value of A 1 minus 2 1 4 plus 6. If 6 is there, then 6 into I should be there. क्योंकि अकेला कांस्टेंट नहीं होएगा, कांस्टेंट्स के साथ आइडेंटिटी मैट्रिक्स हमने लेना है. सो मैट्रिसेस फॉर्म में ऐसे आ जाता है. थोड़ा इसको सिंप्लीफाई करते हैं. -1 -10 5 14. दिस इज 5 is to 1 5 5 minus 10 and 20 plus 6 0 0 6. Let us simplify it. -1 minus 5 plus 6 minus 10 plus 10 plus 0 and this is a 5 minus 5 plus 0 and this is a 14 minus 20 plus 6. Ultimately this come out to be 0 0 0 and 0. So this come out to be a null matrix O. So it means the equation 1 is satisfied. So this justifies the Cayley-Hamilton theorem. तो आपको क्वेश्चन जो आएगा वो ऐसे आएगा, verify Cayley-Hamilton theorem, and the second part of the question is hence find A inverse. Cayley-Hamilton theorem को use करके you just need to find out A inverse. What is the statement of theorem? The characteristic equation will be satisfied by the square matrix A. Should be null matrix. ये हो गया Cayley-Hamilton theorem का statement. हर एक स्क्वायर मैट्रिक्स उसके कैरेक्टरिस्टिक इक्वेशन को सेटिस्फाई करता है. So for finding out A inverse, you just need to pre-multiply with A inverse is equal to A inverse into null matrix. So what is that? This gives us A inverse into A square will give you A, and this is A inverse into A is I, and A inverse into I, that will give you A inverse, and this is a null matrix. Now what is come out to be, यहाँ से 6A inverse, and on the right hand side this should be negative A plus 5I, and you just simplify. This 6 can be taken to the right hand side, and that is minus A plus 5I. Now you can substitute the values. 1 by 6 negative of A. Negative of A will be, A matrix हमें दिया हुआ है. This is a -1, 2, -1, -4, and plus 5 into I. That is the identity matrix 5, 0, 0, 5. So let us simplify it. This come out to 1 by 6 minus 1 plus 5 will give you 4. So the first element should be 4, the second element 2, the third element -1, and next one is +1. So this is your A inverse of the given matrix. तो हम लोग कैले-हैमिल्टन थ्योरम को यूज करके A इनवर्स भी फाइंड कर सकते हैं, और इसी टाइप का क्वेश्चन 3x3 मैट्रिक्स के लिए भी आ सकता है आपको. ये क्वेश्चन था 2x2 मैट्रिक्स का, एंड सिमिलरली you may have the question of a 3x3 matrix. So this is the importance of the Cayley-Hamilton theorem. So let us do one more question by taking a 3x3 matrix. That question will also be similar to this question. So given that matrix A is 1, 1, 3, this is 1, 3, minus 3, this is 2, minus 4, minus 4. And what is given A? The square matrix A is given. Now the question is to verify Cayley-Hamilton theorem for this matrix A, and hence find A inverse. Hence find A inverse mean by using Cayley-Hamilton theorem, you need to find out A inverse. So you know that by Cayley-Hamilton theorem, every square matrix should satisfy its characteristic equation. This is the statement of Cayley-Hamilton theorem. So you just need to find out the characteristic equation. A minus lambda I determinant should be 0. So this will give you, and 1 minus lambda 1, 3, 1, 3 minus lambda minus 3, 2 minus 4 minus 4 minus lambda is equal to 0. Now you can expand this determinant. 1 minus lambda, this is 3 minus lambda into minus 4 minus lambda and minus 12. This is minus 1 into minus 4 minus lambda, and this is plus 6. And by expanding it with 3, you will get this is minus 4 minus 2 into 3 minus lambda is equal to 0. So this is the expansion of the determinant. 1 minus lambda, simplify this. This come out to be, this is a lambda square. This is a minus 3 lambda plus 4 lambda. That is lambda minus 12 will be there, and minus 12 minus 24. And this is a minus lambda plus 2 and plus 3. This come out to be minus 4 minus 6 minus 10 plus lambda is equal to 0. Take it inside. This is a lambda square plus lambda minus 24 minus lambda cube minus lambda square plus 24 lambda. This is a plus lambda minus 2 minus 30 plus 3 lambda is equal to 0. Now you just arrived on the resultant equation. This is a lambda cube negative lambda square, and this lambda square can be cancelled out. 24 lambda and 3 lambda, that come out to be lambda, 24 lambda and 3 lambda. This will give you 26 plus 2, 29 lambda. Check one more time, बिकॉज ये कैंसिल हो रहा है तो हमें एक बार वेरीफाई कर लेना चाहिए कि ये कैंसिल हो भी रहा है या नहीं. सो एक्सपेंशन हमने ये चेक करा. दिस इज 1 1, देयर इज 1 1 3 and 2 minus 4 minus 4. Okay, 3 minus lambda minus 4 minus lambda minus 12 and minus 1 is there, and this into this 1 plus 6. Okay, plus 3 से करा तो minus 4 minus 2 into this. Okay, this is 3 4s are 12. 12 should be negative. Negative 12, negative 12, negative 24. Lambda square is there. This is a plus 4 lambda, and this is a negative 3 lambda. Okay, this is the lambda. Okay, this is minus. This is a minus lambda plus 2 plus 3, and this is a minus 6 minus 4 minus 10 plus lambda. This is lambda square, lambda 24, lambda cube minus lambda square and 24 lambda plus lambda minus 2 minus 30 and plus 3 lambda. ये हम एक बार चेक कर रहे हैं. So this is a negative lambda cube. Lambda square is cancelled out. So this is a lambda, and this is a 24 lambda, 25 lambda, 26 lambda, and 3 lambda, 29 lambda, and the last one is a 24 negative, and this is a 30. 24 is 54. 54 plus 2 will be 56 is equal to 0. This is a lambda cube minus 29 lambda plus 56 is equal to 0. So this is we have. Now we just need to check whether this is satisfied or not. So this was the question we have. Little mistake is there. This is a minus 2 and this is a 2 lambda. Just to rectify this mistake, this is minus 2 into minus lambda. This is plus 2 lambda. And this come out to be 2 3s are 6 lambda. And from this, you can get 24 lambda and 26 plus 6, 32. So this value should be 32 lambda by that. So erase this 29. This should not be 29. This should be 32 lambda. This is also 32 lambda. Now this is the resultant equation we have. अगर वो कहें कि इसी इक्वेशन में इगन वैल्यूज भी फाइंड कर दीजिए, तो ऐसे जैसे हमने करा था पहले पिछले लेक्चर में, इगन वैल्यूज आप फाइंड कर सकते हैं. अगर इगन वैल्यूज हैं तो इगन वेक्टर्स भी आप लोग फाइंड करके दे सकते हैं इफ दे से. बट नाउ लेट अस कम टू द क्वेश्चन. बाय Cayley-Hamilton theorem, what we should have, this should be a cube minus 32a plus 56i is equal to null matrix number 1. So अब ये जो वैल्यूज है हमें पुट करनी है, a क्यूब फर्स्ट, फिर a भी पुट करना, फिर i भी पुट करना, और आफ्टर सिंप्लीफिकेशन दिस शुड बी a null matrix, zero matrix. So for a cube, first of all, we must have a square. And for finding out a square, we just need to multiply a with a. So this is your a matrix, and इसको आप a cube भी लिख लीजिए, इसको 3 बार कर देते हैं. 1 3 minus 3, 2 minus 4 minus 4, and 1 1 3 1 3 minus 3, 2 minus 4 माइनस 4. सीधा ये क्यूब कर दिया. अब मल्टीप्लाई हम 2 बाय 2 मैट्रिक्स ही करेंगे, दो मैट्रिक्स को करेंगे हम लोग. सो लेट अस मल्टीप्लाई दीज टू मैट्रिसेस. दिस विल गिव यू 1 is to 1 is 1 plus 1 plus 6, and next will be 1 plus 3 minus 12 minus 3 minus 3 minus 12. This is 1 plus 3, and this is minus 6. 1 plus 9 plus 12. This is 3 minus 9 plus 12. Third row will be 2 minus 4 minus 8. 2 minus 12 plus 16. This is 6 plus 12 plus 16. And with this we have a matrix 1, 3, minus 3, 2, minus 4, minus 4. So let us write down the value of this. Now it come out. This come out to be minus 2, 22, 6, minus 10, 6, 34, and this is 1, 1, 3, 1, 3, minus 3, 2, minus 4, minus 4. So now multiply here. This is 8 into 1 is 8 minus 8 minus 24. 8 minus 24 plus 48. 24 plus 24 plus 48 minus 2 plus 22 plus 12 minus 2 plus 66 minus 24 minus 6 minus 66 and negative 24. This should be negative 24, and this is minus 10 plus 6 plus 68 minus 10 plus 18 minus 136 minus 30 minus 18 minus 136. So after simplifying, this will give you the value of a cube minus 24, 32 and 96. 32, 40 minus 96, 64 minus 128 minus 184. Now substituting these values in equation number 1. Earlier we have equation number 1, this one. So you just need to substitute the value in equation number 1. Putting the values in 1, this is a minus 24 and 32, 96, 32, 40, minus 96, 64, minus 128, minus 184, and minus 32A. The matrix A is given to us 1, 1, 3, 1, 3, minus 3, and this is 2, minus 4, minus 4, and the last value is 56I, 1, 0, 0, 0, 1, 0, 0, 0, 1. And let us see, this simplification should be equal to 0 or null matrix, because this by your A cube minus 32A plus 56I. So let us check. Minus 24 minus 32 plus 56, 32 minus 32 plus 0, 96 minus 9. This is 32 minus 32 plus 0. This is 40 minus 96 plus 56. This is minus 96 plus 96 plus 0. This is 64 minus 64 plus 0. This is minus 128 plus 128 plus 0. This is minus 184. And what it come out to be? This come out to be plus 128. Sorry, this is minus 184 plus 128. And the last value is plus 56. And it is clear. The first value will give you 0, 0, 0. This is also 0, 0, 0. This is 0, 0, 0. So this is null matrix. So clearly the characteristic equation has been satisfied by the square matrix A. Hence, the Cayley-Hamilton theorem is verified. So the theorem has been verified for the given matrix A, which is of order 3. Now by using using the value of equation number 1, we can find out the value of A inverse as similar to last question. So thank you very much. Thank you, students.
Thank you, sir.